I mean, this is amazing. You guys are a massive video production house and a machine house. Like, what are we looking at here?
Well, what you're looking at is our uh, YouTube right now, but what we
Wow.
are is we're a free academy to teach people CAD, CAM, and CNC. And we have several platforms, so we're kind of a full solution to the industry. So we have our free academy where you can go in and learn SolidWorks, you can learn Mastercam, you can learn how to run a CNC mill. And then we have CNC Expert where you can go and you can take certification exams for free in all of those platforms. And then once you start making your own parts, you can share them on CNC Expert as like your personal
Yeah,
portfolio.
build your work that you can show people. I saw some of the screenshots of some really gnarly like hex designs and stuff on there.
Yeah, so people talk about the skills gap and the lack of skilled labor and stuff. So we're solving the skills gap with our free academy. We're
Yeah.
giving people legitimacy through our certification program, and then we're giving you a free profile that you can use to find vendors, find employers, find employees, find
Hmm.
anything that you need in this industry. You can find right there.
This is
So it's a
amazing.
platform
So
for machinists by machinists.
So a lot of us maybe won't be getting a machined component done by Titans of CNC, but we can all go and check out CNC Expert, your content. You were telling me your team and you, I mean, you're posting a couple times a day. I mean, you're
Yeah,
active most of your day on social, just interacting with people with the purpose of enabling them, empowering them
yeah,
to do
and
more. And that's awesome. You're on live design, which, unlike our big live show, we always, um, like to invite special guests, and it's great to have you on here. You guys right now are seeing a video of our bowhead story, but yeah, Barry is joining us from Titans of CNC down in Flower Mound, Texas. Dude, I was looking at the weather, 101 degrees coming up here.
yeah, it's a lot cooler inside the building. So I try to
Yeah.
stay here.
Yeah, man, you guys have such a beautiful shop. What's that behind you? I mean, you got a disco ball. I'm assuming you didn't machine that, or did
I
you?
I did machine that for one of our videos.
No, I have
Yep,
not seen that one.
yep, that was a fun one. You might see pictures of me around with a big afro wig on, and uh,
Is that a tutorial also on CNC Expert? Like, hey, the disco ball with Barry, and it's
well,
like 10
you know,
hours of just CAD work.
honestly, everything we do is a tutorial. So a lot of the things that you'll see on YouTube are what I like to call edutainment. So we try to teach something that's also interesting in the process, like the skateboard video. Making that skateboard
Oh,
was
you have
fun.
that in front of you? You were showing that earlier. Can you hold that up for the camera and tell us real
I
quick?
do. Can the camera still see me, or is it still screen sharing?
Yeah, we'll get it up there. We got Andrew Gross producing. What's up, man? Are we live, by the way, or what's going on? I think we had a couple minutes. So yeah, show us this skateboard. It's not the example for today, but this is a gnarly video you got to check out.
Yeah, and that I forget how many views this has now, but it's around 1.5 million. And so while it's an entertaining project and the video was great, I mean, several of our editors here were sponsored skateboarders. So we made something fun. We showed how we made it. We showed how we modeled it. Showed how we programmed it, and then
How
we
did
got to
they
show.
react to the? I mean, the geometry is amazing. I would love to
Yeah.
have you back for a third live design. You show us that, but like, how was the ride of it? I guess the stiffness, the weight, kind of the
Oh,
response of
it
it.
was it was perfect. I actually made it to
Oh,
where
groovy.
it weighs the same as a wood board,
Yeah.
and it has the exact same geometry as the board they gave me. So it
Did
worked.
you do like a texture on top to emulate like a grip tape, like a diamond finish, or what was up
Yeah,
up
yeah.
top?
You can see that it does have a texture to it. So,
How did you guys? Oh, that's machined in. Just what
yep,
little
machined into it,
dimpling?
permanent grip tape.
Yeah, that's fantastic, man.
Oh yeah, man, it was super cool. That was probably my favorite video. And then
Now
like
is that a tutorial? I mean, in that video, do you get into how you would machine this? And I mean, like, how deep do you get?
we got pretty deep in the programming side of it and the method that we used. The modeling we didn't get into all that much. It was kind of simple. I mean, I just modeled the quadrant of the board, the surface, and then just mirrored it around, and
Mirrored
then
it twice.
yep, and
The,
then thickened it.
nice. Well, hey everyone, welcome to SolidWorks Live Design. We have a very special guest today, our friend Barry Setzer from Titans of CNC. Welcome, Barry.
Thank you. I'm glad to be here.
We were just chatting, rewind, a couple minutes. We were talking about this skateboard project, part of all the massive, awesome edutainment video content Titans of CNC does, in addition to being world class, machinists. It's all about enabling and training and just making the community stronger with their skills, which is really the purpose of live design, right? We're here to actually get
Yep.
in, show the software. Barry was showing us some of his videos on CNC Expert, and you talked about like 1.5 million views, dude. Our top viewed live stream so far was last year's episode of Lofted Aerospace Parts with Barry Setzer.
I
That was you,
remember
man.
that. Yeah, man, that was an awesome video. It was cool to see all the interaction coming in from the commenters. So
Yeah.
y'all feel free to ask away today.
Yeah, that's a good point. You guys had so many great questions about specific tools, because what Barry brings is a really unique and keen perspective from taking modeling projects and trying to fabricate them, getting them built, a lot of times just based on old 2D drawing information. So after this episode, go back and just go to our YouTube channel, Live Popular. It's the top episode, 200,000 streams so far. And you showed us some awesome tools, Barry. You showed us Sketch Picture. Anyone here like Sketch Picture? Give me a SP in the chat if you're a Sketch Picture fan. And dude, you were dropping gems on us, like, hey, put the Sketch Picture line in between the pixels. So you basically outlaid a whole bunch of powerhouse tools in some really practical examples of bridging the gap that exists between design and fabrication. And just look behind you. You have so many amazing examples, which are all tutorials that Titans can teach you, by the way. And this is because Barry's background, you were telling me, started in manufacturing engineering, right? Really that connector between design and fabrication. And so it's a really great perspective you have. I appreciate you being here. What did I miss, man? Other than,
I,
yeah, you're going to
I
teach us
mean,
a
this
lot of
month,
powerful tools.
I actually started off in my grandfather's machine shop doing piecework, just assembling components of his own products.
Yeah,
I was
okay.
a kid, so from the time I was maybe seven to
What was
10,
your grandfather building?
he was building fishing rod holders for boats in the Chicago area. So,
Oh, okay. I'm at Chicago, mile from Lake Michigan. I mean,
yep. So
yeah, gets
there
pretty
were
choppy.
there were tons of boats out there that had his stuff on them for years and years. And then I went into working at my dad's machine shop, and just one thing led to another, and I ended up doing a lot more engineering than I was doing machining, and I liked it, and so I thought, wow, I should probably be an engineer and not a machinist. Well, then I got into engineering, and it's like, yeah, you're going to spend all day reading specs, going to these
Mm.
manufacturer websites, repair manuals, and I was like, man,
Design review meetings.
yeah. It's like, not only do I not get to do 3D modeling anymore, I don't get to do machining either. So it's like,
Oh,
I'm going back to machining. I
oh
like doing
man.
stuff.
But you are a powerhouse SolidWorks user and CATIA user and background in aerospace. I mean, just again, guys, you got to go back and watch last year's live design aerospace parts, because you showed us some really cool formed examples with the sketch picture, point cloud data, and just some really nifty tips and tricks. The only thing I wanted to see was more of it. And I guess that's why we have you today. You have a whole new part I know you wanted to show us, and kind of start with
Yeah.
the workflow you guys didn't even get to touch on when Sean was down there in Flower Mound, Texas, which, by the way, guys, just north of Dallas, Fort Worth, right?
Yep.
Already a steamy 100 degrees. So Sean was down there last year, and you're showing him some good examples, but dumb solids, right? Just what kind of direct editing tools we can use to take whatever format we're getting. Someone sends us a step file, someone sends us a share and markup, and downloads the step file. What can we do? And I know there's so much modification that happens between the design model and fabrication, and that's a whole other topic. I got tons of questions that I want to understand about how we can close that loop with mutual understanding. But I guess that's what you're all going to get out of today's episode, is a real good triangulation of SolidWorks tips from an expert with a lot of good perspective from manufacturing, which I guess really informs then what your CAD should look like, right, in terms of precision, quality, and robustness. So enough yabbering. Barry, do you want to bring up the model you were just showing me? That would be a great place to start.
Sure. Let me know when you can see what I can see.
Oh, this is great, man. And he by the way, big thanks to Barry for downsizing his jumbo wide 4K and his beautiful workspace there down in Titans. But so this is an aerospace component, and maybe I'll let you share a little bit more of the background and maybe what's the girth of this thing. It looks very slender and difficult.
Yeah, so it's roughly 12 feet long and maybe 8 inches wide here at the widest point.
Twelve
This
foot
was,
8 inch. Yep.
yeah, this was probably the most difficult part I ever had to model in my career. Uh, Took me several months to finish it, and it may not look like much from here, but once you understand a little bit about aircraft drawings, all of these surfaces are lofted, they're all tapered, nothing's flat. It's got all these different tilted walls and fillets everywhere, and just it was just a nightmare. And it was a hand drawn
Oh.
drawing that was just
Well, let me say to everyone out there, like Barry showed me under the hood already, there is a whole surface modeling masterclass in terms of legacy drawing, what TIFF files or whatever, scanning them. I mean, you said you hunted out 20 drawings. You're creating line art, surface extrudes off sketch pictures. I feel like that's a whole nother topic. But I don't know if we have time. If you guys want to see that, let us know in the chat. Do you want us to get back into drawings, modeling this from legacy? Because I also loved where you were starting here, which is hot mess. I mean, there's not even a material on this thing. It's a dumb solid, if I can say that, because I don't know, is a step file like this? But
yeah,
this is typical of what you get and what I'm sure we all end up starting with, right? A dumb solid, one way or another.
yeah. And like for me, I'm lucky because I actually modeled this part and then just saved it as a dumb solid to kind of simplify it for this
That's right.
video.
That's cheating, but only a little bit.
Yeah,
Because
yeah,
the quality, the fidelity, the kernel is going to be the same. But barring all that, man, I mean, what is the material? 12 feet, 12-foot beam. It's a spar
yep.
for
It was aluminum. I think it was 7075.
7075, like a T6 or something,
Yep, yep.
for a
And
primary aircraft structure.
yeah, this
Uh,
was something that went into a wing of an aircraft. Now, granted, I changed this part considerably, so nothing on it is the original dimensions or anything. So
well,
make
it's a very sophisticated beam that you're not going to be, I guess, welding up plate by plate. Like this thing is machined out of a solid billet of 7075. So you want to get this right, I suppose, the first time, or that's a ton of material to be
that's right, and a
taken
ton of
out just to get to the
time,
end,
a ton of time. So
dude.
all these
Um,
undercuts and stuff. Yeah,
So let's assume, and one thing that Barry highlighted in his last stream, which is that your data can come from anywhere. It could be sketch pictures, it could be TIFF files of Mylar drawings, it could be IGES, it could be a point cloud, and you need to be agile.
yeah,
And one of the things that I appreciate now after watching that is like, no matter the model is perfect, right? It's watertight, it's a solid, but you can't just put this into CAM and expect, feature recognition to carry the way. There's a lot of specific modifications you do to this. Talk about fillets, maybe some ribs, some setbacks.
yep.
Uh, how are you going to accomplish all that? Because you're definitely not going to put an ECO in and go back to the original SolidWorks or get involved in any of that. You just need to make the changes so that you can go and program it. I mean, what are some of the things you're looking at right away that need to change after you get this part?
Well, you look at the part like this, and you can't. Feature recognition is great, but on something like this, you just can't do it because there's so much going on. I mean, so many lofted surfaces, so many crazy fillets. I mean, I showed you the actual tree yesterday where I think it had, I was on like fillet number
Four. I thought it
270.
was 400. I mean, it was, guys, again, it's a
Yeah,
master class.
it, it, it was brutal. But, when you get a part like this in machining, a lot of times, you'll get a model and say that this is a Rev F model, but then there'll be like, 7 EOs after it that are changing things, but this Rev F model doesn't have that. So as the machinist, I have to look at those EOs and I have to modify the features that are required for the finished part because it won't match this model.
Oh man, so you end up having to put all the input together and basically be the final CAD
Yep,
designer.
yep,
And again, this is something I want to come back to. If we have time, is like, then how do we get that back in engineering hands, right? Like, there's so much modification that happens during fabrication, installation.
yeah. And
Like,
it's funny, a
can
lot
that
of the times you'll model a part like this for a third party, and you'll ask them like, hey, do you want me to send you the model so you could share it with your customer? And they're like, nah, we'll
yeah.
never use it.
Oh yeah.
It's like, okay.
Oh. Okay, so yeah, there's a lot of stuff you can't just send this to CAM. So like, again, what are the things you're looking at? What tools are you
Yeah,
going to be deploying here?
so part of being a good designer or a good CNC programmer or any of that is not only being accurate with everything and paying attention to detail, but it's also about being fast. I mean, a part like this, you can't spend a year on the model and then, another year programming it. You have to get things done fast.
Mm-hmm.
And in my experience with SolidWorks, I've been using since 2005, so almost 20 years now.
Almost, man.
Yeah.
Yep.
And what I've found is anytime that I'm struggling with something or something seems too hard, that usually means that I'm doing it the wrong way. And so I wanted to talk a little bit today about some of the things that'll make you faster, things like understanding what certain errors mean and what's causing them, how to fix them, and how to take some shortcuts that, even if a shortcut only saves you, say, 5 seconds a day, over 20 years that adds up. So sometimes it's the little things and sometimes it's basic things. We talked a little bit yesterday about how there were times where I was doing things like the dumbest way imaginable for years until I saw somebody do something and I was like, wait, how did you just do that? So there's going to be things in our live today that will appeal more to beginners. Some of it will appeal more to experts, but I kind of wanted to cover a full gamut so that we had something for everybody.
This is going to be fantastic. Yeah, Barry was showing me some stuff with, delete face. I mean, last time we were talking about offset, copy surface. I mean, just everyday tools you need to know about. And we were talking yesterday about these are things you learn years on that you look back and you're like, oh man, if only I had known about delete face earlier or offset surface or like convert entities. These aha moments. So it's not just, using S key and all these shortcuts, which I know maybe you can dabble some of those in, but just again, how do you take some of the best tools? I mean, put them all in one tab of your toolbar,
Yeah,
and then like this is your everyday kind of what's on your tool belt on your machine feed there. So, all right.
yeah,
So what's the first one you want to deploy on this? I mean, what's got
yeah.
to
Well,
change?
since you brought it up, we'll start with something super simple. If you look at all of the tabs that we have in SolidWorks, there's a lot of stuff in there, but what sometimes you might not realize is there's even more that's not shown up here. So, for me, I know the tools that I use on a
Barry's
day-to-day
awesome
basis.
tab.
Yeah, so like I've created Barry's awesome.
Okay, no, pause here. I mean, this is the one oh yeah, delete body, delete key, body, delete face. Yeah.
Yep. And you know, I really like the SolidWorks user interface for these tabs and toolbars. Like if I wanted to throw something else on there, I just go to Tools, Customize. If I could get down there, and then just go to
Yeah.
Commands.
Mm-hmm.
And I love the fact that you can search for a command. So if you already know what the command is, you can just type it in there and find it. Like if I'm looking for measure, say I want to put measure on
Oh
my
man. Well, you know what you can do now. Are you in 2023, by the way, or what version?
um. Oh, why are you asking?
S key command search, by the way. Short. You bring up the shortcut bar, and the command
Oh
search is
yeah,
right there. 2023,
yep. But
and then you
if
can.
you're not using 2023, you can just find the command you want and just drag it up to your toolbar. Done
Oh, look at
deal.
that.
So now I got measure up here.
Okay.
But I I like little things like that because this toolbar saves me maybe a split second of going to a different toolbar. And as I use this toolbar more and more, you get that muscle memory of knowing where an icon is. You don't even really look at the picture anymore.
Mm.
So, that's just one little tiny thing that helps. But I like the fact that you can create your own toolbars and put your most commonly used things up there. But when you start looking at this part, you know, let's just say that they come and tell you that they want a um, additional rib, and let's just say they want to go 3 inches off of this face and put another rib here that goes from this wall to the wall next to it. Now,
Okay.
whoops, come here,
I
mouse.
imagine that's got to be tapered or drafted. I
Yes,
guess is that
yep,
the right way to say that?
yep. They're drafted and they're also tapered outward, so you can't just draw a rectangle on the floor and emboss that up. Um, you know, you there's a lot of things that you can kind of do to cheat it, but
Mm-hmm.
in this case, I wanted to show two methods that I use when I have to do something like this, especially on contoured parts or parts where I don't have edges that I can convert. So the first way we're going to do is we're going to go ahead and put a plane in. And we'll
Okay.
say 3 inches off of that face.
Is that going to be the mid plane?
Now I'm going to use this as one of the outside
All
planes.
right.
We're going to create a loft here. But to get the geometry of these walls and floors, to get actual edges that I can use here, the first tool I'm going to use is split line. So we're going to use this
Oh,
plane,
interesting.
and then we're going to select the faces that we want to.
Oh, dude, I haven't used this in years. I mean, with simulation, this was like a godsend to get this because you could split where you want to apply a force.
Yeah,
So
yep,
show that one more time.
sure.
That is one of those tools we were just talking about. If you are just learning that now, again, tell me that years ago when I started. So
Yeah, and split line I think is part of the mold tools uh,
oh man,
toolbox, but again, I have it out here on my Barry's Awesome tab. So all you got to do is click. We created our plane. We're going to pick split line,
mm-hmm,
intersection,
mm-hmm.
and all of these things are useful. You just got to play with it to know what each one
So
does.
you're not making a sketch or trying to do some 3D sketch or multiple planar sketches and convert entities. It just slices all those faces with this plane.
Yep.
And you could probably do surface bodies if you want to do some kind of curvilinear intersect.
Yeah, we could. And I kind of
Wow,
just
man,
wanted to show
that's great.
this so that we can see how we can get those edges at the exact plane where we need them. And now that we have those edges, we can do just a plain sketch on that same plane. We can convert those edges.
Now you can do that.
Whoops, not that face.
Yep. That's brilliant.
Yep, and then we just draw our line across the top. Boom. Now, that's one section of our loft. For the second one, we're going to do it a little bit different way, but I like this way because I've used it for a whole lot of different things, and a couple of the other guys here have also found it useful. So now we're going to create another plane, 1/8 of an inch off of that one. And now, rather than using split line, and sometimes you may not want to use split line because you want this to be a continuous surface when we get into machining for our CAM software. So what we're going to do this time is we're going to select that new plane, and we're going to do cut with surface, and we're going to cut our part off that plane. Now we still want the stuff that we cut away, but now we want these edges here. So what we're going to do is on that plane that we used to cut, we're going to sketch. We're going to do just like we did with split line. Draw our little top line here.
Mm-hmm. Dude, you are stealing edges. This is great.
Yep. And I like to call this a ghost sketch.
A ghost sketch. Okay, I was gonna say, what do you call this? This is.
Yeah. So right now, if I were to close out of this sketch and delete that surface cut, my sketch will have rebuild errors in it because it's tied to these edges that are no longer going to exist. And that's something that, going from like CATIA to SolidWorks, SolidWorks' tree is chronological, and I love that about it because, what you did here, can't exist until what you did before. Oh, my mouse is going crazy.
Zoom to fit. Yeah, there you go. No, so in CATIA, what would be different about that? The references, the edge references.
Yeah, I mean, back when I was using it, I'm not sure what it's like today, but it had like a separate tree for curves and separate tree for surfaces, and it was just really different to me because I'd used SolidWorks for years before I got into CATIA, and my bread and butter has always been SolidWorks. I've always been a little bit better with it, but with this sketch here, so that we don't end up getting that rebuild error, we're going to just right click off in space and say display delete relations.
Sure.
We're going to delete all of our relations.
Yeah. Okay.
And then we're going to pick our whole sketch and fix it.
Sure. It's like a in context assembly, part modeling, no references made.
That's right. And that's why you got to be careful when you do this, not to sketch on this face, but to sketch on the plane. Because if you sketch on this face, that face is going to go away here in just a second, and then you're going to have another rebuild error for not being able to find the sketch.
Oh, this is great. So just to recap the last couple minutes, what Barry showed us is what he's calling a ghost sketch, which is the next station for his loft. The first one, the plane one, he was showing us using intersect or split
Yep.
to create an intersection. That's great, but here he doesn't want to create any sharp edges, right? Just have those sketch entities. So, a lot of, I think, under the hood SolidWorks model tinkering probably comes down to techniques like this. This can be
Yeah.
very handy to get the edges you need to then create one more station, or is this it for your loft? Do you need to
This will
create
be
another one?
this will be it for this one.
All right, let's see the next step here. I know everyone's eager to see, like, where do you go from here?
So once we get out of there, we now have this sketch using those edges that we just created with that surface cut. But now if we delete that surface cut, our sketch is still there.
Nice.
Not dirty. And now we have our whole part back.
Yep.
So
that's
the next
great.
thing I wanted to show, a lot of getting good and fast in SolidWorks is when you get errors that you understand what they mean and why you're getting them. So right here, if I wanted to create this new rib, I could just loft it.
Kind of clicking it in the same spot. So those
and I talked about that a little bit.
The last one, I was gonna say the tangents or the connection lines. Yep.
Yeah, and we'll show that again real quick. Back when I first started lofting, I had no clue what was happening. I would just do like that, and it's like, that is not what I want at all. And then one day I accidentally drug this little control ball here, and it was like, oh, so I just got to make sure that they line up with each other, and that can be kind of tough if you have two sketches that have like a different number of sketch entities in them, but usually you'll be able to figure it out pretty easy. So
you have same number of segments, which is key, and then when you select it, just that kind of just same general area is going to really help you out. And then there's obviously the curvature display on the bottom if you had more than just probably two sections there. But yeah, that looks great. I mean, that's going to follow the surface.
Yep.
And I would have probably done something like trying to offset those surface, done the planes, and then done like an intersect or a combined type thing. But this is great. I really love what you did there.
And that's the beauty of this is, I will never say that I'm showing you the best way to do this, but I'm showing you a way.
It was fast too. We're 10 minutes on that one.
Yeah, and that's with me sitting here blabbing the whole time. But
you and me both, my friend. But it's fun. It's our show.
Yeah,
and folks are enjoying it in the chat. We got Michael Paul. If you use intersection curves, you don't have any dangling relations. That's true. Yeah, you could also use an intersection curve and not split the face. But I think that's a good point you made last episode, Barry. It's like you said at first there's hundreds of ways to do something. There's no right or wrong way as long as you end at the result you want. And then later in the show you said thousands. I'm thinking, okay, there's maybe dozens and at least two that are going to get a hot debate. But either way, if you have more ways to get the edges you need for your loft, that's fantastic. So
and this particular application of these two methods that we just used may not be the best example, but there have been times where intersection curve wouldn't work for me for something, the split line wouldn't work for me for something, and the ghost sketching did. But just knowing the methods that were available to me, when one thing doesn't work, then I can use one of these other ways. And I think that's super important for anybody that uses a design software like this every day, is just knowing what's out there. And having worked with this for so long, I can tell you right now that because I have this new feature merging with my solid body, I know right away that when I click check mark, this is not going to work. Of course.
Then feature, man. Oh, surface. Oh, no, it did as a surface. Okay.
Oh, that's what happened. Ha!
I wasn't sure if you meant to do that. Because, you could definitely do the surfacing route. Use plane, intersect tool.
Yeah, I meant to use lofted body.
And what's cool? I was thinking you could actually, if you had to, tilt the planes by a degree or two to actually make I guess it would be a planar line. But so it has to be drafted, right? How are you going to accomplish that?
Well, this particular one doesn't have to be drafted. All these other ribs aren't.
Okay.
They're vertical, but
you can do vertical you can machine that then.
Yeah, but we could have done a similar thing and just sketched a 3D sketch here on this wall at the angle we wanted, and then done the same thing, created a plane using that line and gone from there. But to get into the problems of what's about to happen here, so I want these two bodies to be one solid body together, but if I tell it to do that, it's going to tell me no. and it's saying that it would result in zero thickness geometry. So what it's telling me is that
Sure.
there's, tiny little gaps, or literally what it's saying, zero thickness geometry. So it's not able to merge that body for me. So there's two different ways we can fix it. Um, I'll show both. So the first is we can use guide curves. So
Mm-hmm.
every edge that we have there,
Okay.
we're going to pick each one.
Or else it's just going to do a linear interpolation between your sketch entities unless you guide it.
Right.
And the surface, even though it looks straight, could have, especially if it's imported, who
And
knows what kind of variation to it.
and they do have some curvature and stuff in them. So
Mm-hmm.
if I give it guide curves now, it should work. And it did.
Oh man,
See,
that's fantastic.
yeah. And, maybe,
And you have one body, yeah. Just to double check, one solid body, so you can go ahead and apply that generous, fillet in the inside. That looks
yeah, exactly.
pretty generous.
And alternately, if we say didn't want to give it guide curves, we could just not merge it.
Okay.
Now we have two solid bodies in our tree. We'll hide the one, and then we're just going to offset the surfaces by just a tiny bit, 10 thousandths.
Yep. Overbuild it, right, and then let it just kind of blend together magically by the power of solid continual
That's right.
geometry. Blend thine self.
Oh,
Oh
wow.
man. Yeah,
Surface.
that's a great example. Again, I could have seen myself offsetting those inner channels, but that creates some pretty heavy, big surfaces. That's a lot of overhead. If you're doing 100 of these types of little tweaks to the model, this is a very, I think, economical way to do it.
Yeah. And it's fast and easy. And sorry, I was
Yeah.
using offset surface because I'm so used to clicking on that, but move face.
Move face. Okay, so offset surface would create an additional surface body, but yeah, move face just does that and then knits it,
Yeah.
creates that extension.
So now if we show our other solid body, you can see that they're intersecting with each other.
Yep.
So now we can just use combine.
Yep. By the way, guys, multi-body modeling, we've covered it several times, 6 times now on Live Design. If you go back, I think, was it December? Brad Williamson hosted an episode with me, and we looked at my workbench out there, which is a giant dimensional lumber multi-body modeling. So we talked about just that solid bodies folder, how important it is. And like at this point, getting into any type of modeling like this, if you're new to SolidWorks, just master the solid bodies folder, right? And having that shown all the time. Right now, I think it auto hides it sometimes. Like you don't want any of that. You want to be a master of your bodies folder, right?
Yep, that's right. And you have to be constantly cognizant of what's in there, because there's been a lot of times where I thought I was working on a solid body, but realized later something I had done, deleted a face or something, ended up turning it into a surface body. But yeah, I always keep an eye on what I got in there. So
This is great, man. Hey, time check. We're at 30 minutes. So let's keep going. Great to see everyone in the chat. Hey, welcome. Great to have all your participation. Ask some good questions. Make some comments. Barry just created a really nice rib. We need to make so I was looking at that fillet on the other ones. Like, that's pretty big. Is that easy then for you to then mill out when they give you just nice chunky fillets like that?
The bigger the fillets, the cheaper it's going to be to machine in almost every case, particularly wall fillets.
Okay.
So, I did a SolidWorks tips and tricks video on design for manufacture, for our own YouTube channel.
Yep.
And I talk about a lot of this, and I give the rules. If you're going to make a wall fillet, don't make it an even fractional number, because most of our cutting tools are going to come in those even fractional numbers. So if you make it exactly 1/4 of an inch, I have to use a tool a step down from that. Otherwise, my tool path will have a sharp corner there, and I'll get a bunch of chatter in that corner. So what I tell people to do is try to go 10% over an even fractional number. And that holds for metric too. Don't make a wall fillet 6 millimeter, make it 10% bigger than 6 millimeter.
Oh man, that is another gem. Okay, so to prepare for manufacturing, machining, oversize my fillets by 10%. Does that get into something you were telling me yesterday about having to use delete face, copy surface, these types of tools to change the size?
Yep, and that's what I was going to get into.
Oh man, let's get into that. Let's get to some more technical nuggets. This is fantastic so far. So yeah, man. So don't apply the exact fillet you want. Oversize it.
Yep.
What if the fillet is not a feature? I suppose.
And yep. So let's get into that. So I've got a couple of suppressed cuts here. I figured we would just focus on a simple area. So we'll go ahead and switch to this. So all I did was cut away a bunch of the part just so it's a little more clear what we're doing. So I have this imported body here. When I click on this fillet, I can't tell what size it is. If I use measure, it can't tell me what size it is because it's an imported body. It's a lofted feature or, swept feature, something like that.
Wow.
So the first problem that I have is how in the world do I measure that? And this may be kind of basic, but it's one of those things that I happen to do a lot. So I'll go just create a 3D sketch and I'll pick a 3-point arc.
Okay.
And just snap that sucker on there. And now I can check that, and it tells me that's a 190 radius.
That's smart. Good job. I think we've already had people mentioning two tricks I'll use on Monday. Gilham, thanks for being here. Marty, yeah, that's awesome. This is a great one. Getting a quick measurement.
Yep. So now with this weird surface, I was able to get that radius I needed. I didn't need to keep that sketch. It was just for me to get that measurement. And I don't know about the rest of you, but in my keyboard shortcuts, M is measure. So keyboard shortcuts are another good thing. But let's say that, that 190 radius would mean I'd have to use a 3/16 end mill, and that's still a little bit too close to that size.
Okay.
But let's just say that the drawing would allow me to use up to a 0.3 radius there. Well, I want that as a machinist because it's going to allow me to make the part faster and it's going to look better in the end. So how the heck do I get this bigger fillet in there?
I would offset. I don't know, man. I mean, it's a rat's nest because there's no fillet feature, so you'd have to offset that, then offset the adjacent faces. I mean,
right. So I'm going to show a couple of ways of how to do this because this is probably one of the things that we modify the most as machinists. Because a lot of engineers, nobody teaches you in engineering class to go 10% over a fraction.
No.
Right, because I mean these are things that take experience in the machine.
Half the people here say they have never heard of that.
No, and most people, I was an engineer, or at least a designer, and I just threw whatever looked good in there to me. It's like, how's 1/4 inch look? Oh, that looks good. I'm gonna leave it.
So but you said this a few minutes ago. Like the larger the radius on these wall fillets, right? The cheaper, the faster it's going to be, right?
Yep. And for floor fillets, just to touch on the floor fillets, that's not the case. A floor fillet in the YouTube video that we did on design for manufacturability, I think we called the video something like, taking a $50,000 part down to $500.
Okay.
And I have a chart in that video where I tell you, here's the floor fillets that you should use, because we got two things happening. We have a cylindrical end mill that we're going to get into that corner with. And that end mill has a radius on the tip of it, which is what creates the floor fillets.
Sure. So the tool is now perpendicular down into your screen as we're milling out in this setup.
Yep. And so, generally speaking, our end mills are going to have pretty small nose radiuses on them, 30 thousandths, 60 thousandths, 90 thousandths, 1/8 inch.
Makes sense, yeah.
So if you make a huge floor fillet, now we're going to have to surface machine that by going back and forth over that surface hundreds of times.
Because you're extending the length of the root, right? That you have to get down and make a contour for.
That's right.
Makes so much sense. Okay, so wall fillets, bigger, generous, because that's in line, or I guess parallel to the tool. So you got to be thinking about your tool path and the tip radius. You're saying the nose radius.
Yeah, and something that engineers can do to really help out, if those radiuses don't really matter to you, give us a wide open tolerance that will still work for fit, form, and function, but tolerance can make a big deal for machining a part. And if you've done like me and just throwing a random radius in there just because you like round numbers, tolerance can fix that for us. But as the programmer, I have that tolerance, and now I want to change this fillet. So what I'm going to use is Barry's awesome tab here. We have delete face. Now, a lot of us have used that before to delete a face, and that's just exactly what it does. If we look at our tree right now, we have one solid body. So if I delete these couple faces here, I'll stop it.
Yeah. It's just open.
Yep, it's just
Wide open. Yeah, that's
yep.
terrible.
And now it became a surface body. So something that I really liked that I only started using maybe a year, maybe 2 years ago was this delete and patch.
Yes.
And whenever I'm working with fillets on any kind of complicated surface geometry, even though this doesn't look complicated in this state, it is. I try to keep things simple. So with delete and patch, I'm pretty sure if I pick all 5 of these, it's not going to work for me.
You might have to pick those other 2 legs, but that might actually make square.
Which is what I'm going for at the moment.
Oh, look at that.
So sometimes, it's just tough because there's so many vertexes and so much weird stuff going on, like where this face is meeting. So we're just going to keep it simple, and I'm going to pick one at a time. And you see what it did? It completely got rid of that fillet and gave me a nice edge.
I was going to say the best tip with delete face is it's powerful, but you have to do things sequentially with multiple features because it's basically deleting it and then extending the surfaces. I guess I was going to ask delete and fill. I've never really used that as much because it seems to be more interpolation. But do you ever find a use case for delete and fill, or else delete and patch 100% is the go-to? Yeah,
I've tried delete and fill several times.
Yeah,
a lot of times I get some pretty weird curvature out of it, but I have used it before with success. But that's just another one of those things, is understanding how the tools work and when is the best case to use them, and understanding, like, we just showed, we tried to pick 5 fillets, it didn't work. We tried to pick 7, it didn't work.
Yep.
But sometimes you just got to step back and say, okay, let's take this one step at a time and see what actually
because it needs to delete it and then patch it, and the more faces you're selecting are the more then edges that are exposed that it needs to algorithmically apply. So now that you have this hard edge, I imagine, could you go back and just apply, or so sequential delete and fill, or sorry, delete and patch. In the chat, let us know, do you have a good delete and fill? I mean, R&D explained it to me one time. Delete and patch is like a 2D. Like, if you're going to cut a hole in your drywall and then put a patch in, right? It's going to be 2D. It's going to use planar. Delete and fill, I think, to your point about like curvature, it tries to do some kind of 3D based fill, but I don't know exactly what it's attempting. But let us know in the chat if you understand that one, or else, Barry's just showing us delete and patch. And by the time I'm done talking, dude, look at that. So now you can apply whatever you want, right? It's a solid body.
Yep. Got our nice solid body. We can start throwing fillets in there, whatever size we want.
Okay, so what would you say? You said it was a 0.19 radius that the customer put into their design geometry, guys, right? 190 on the design.
Yep.
You said oversize that.
Yeah, and so you see, I just tried to put a 190 radius back in there, but I didn't get any preview. So that tells me there's probably something sketchy going on here along this edge. So rather than use just our basic fillet, we're going to use face fillet.
Oh, dude.
And so now you see it works. So we had sketchy stuff going on in there. And just for kicks, we're going to put that same 190 radius in there. Now, when you have a simple wall radius like this and you want to increase the size of it, it's super simple. If we want to shrink the size of it, sometimes that can get a little bit harder. But one thing I like about increasing the size of a fillet is you don't have to go through that whole delete face thing, so long as it's not compounding with other fillets.
Mm-hmm.
You can just do a face fillet and jump right over it, and then put your 0.275 fillet in there, and your new fillet will jump over that.
That's a very gracious feature. Thank you.
Yeah, I love that.
Thank you, face fillet. Oh man, that is awesome. The other day I used full round fillet. I'm like, I haven't used this since Essentials class.
No, man, I love using that too. There's so many good, valuable tools in here, and that's
Barry. Can you go back to your fillet, because I wanted to point something out. You said it really well. It's like there's no preview, so I know it's not going to work. Now you see the full preview, partial preview, no preview. Be very wary of that, because I found it's kind of a sticky setting. If you do like no preview, because you're selecting a whole bunch of stuff and it's going to be a performance nightmare to wait for it all to select, you're like, okay, no preview. I feel like session to session it'll come back and be like no preview. I'm like, oh yeah, show preview.
Yeah.
So make sure you guys have that muscle memory of full preview on your fillets, because if it shows it, it's going to make it, and that's right away your instant feedback.
Yep.
Great, man. Hey, what's up, Matt? Yeah. Okay, so we got some good chat here. We were just talking about how wall fillets like this one, heck, make it generous, add a wide fillet, make it large because that's going to be fast and easy. For the floor fillet, we're talking about you want a smaller one. So we definitely have some size recommendations. And then we were talking about oversizing it at least 10% or just applying a wide tolerance to let the machinist give them a wide berth in terms of the radius. So now you could, of course, proceed and do the floor fillets
Yeah, we could, except
from
I'm going to
there.
stop here and show something completely different.
All right. All right. Well, you do that. Deepak had a good comment. Sorry, it's going so fast. Delete face. Oh, yeah, FeatureWorks. So we all know FeatureWorks. You can like bring in that, dumb solid and like you could right click a fillet and edit feature and it like magically recognizes it. I guess Barry's showing us if that doesn't work, but I am curious, Barry, in your experience, do you try FeatureWorks first and be like, yeah, see if you can recognize these into and backtrack them into those editable fillet features? Like, how often does that work for you?
It works. I tend to limit myself to using that in simpler parts. And like for this particular part, when I click on the original fillet, it didn't give me any kind of indication that it was a fillet, even using measure. So right away when I see that, I
Mm-hmm.
start having doubts that FeatureWorks is going to be able to recognize it as a fillet either. And it very well may. But like you said, I'm just trying to show what happens when that doesn't work.
Exactly. These are the tools you need because sometimes you got to dig in there and like, it's not just a paint job. You got to mess with the framing now
Yeah,
that you're like digging into the wall a little bit in your model or your house. In my analogy, like, oh
yeah.
man, this is great. These are powerful tools. We've talked about split, delete face. So you want to switch gears. While you switch gears, I think there was an interesting question earlier about the difference between a fillet and a chamfer. And I think all of us who've used SolidWorks know it's just straight cut versus a rounded cut. But I guess let's take it in the context of machining. Barry, how do you feel about like chamfers on a model?
So
Where do they make sense versus no? Just dude, don't do that. I mean, save that for your additive prototypes, right?
if you are on an external edge and you put a fillet on there, it makes it infinitely harder to machine. If you put a
Okay,
chamfer there, it's easy.
you're just
So
slicing well. You tilt the tool and just slice it.
you can do that, or you can use a chamfer mill that already has either a 90-degree point, a 60
Sure.
degree
Okay,
point.
like a router bit. I'm thinking.
Yeah, similar to that. And then for a chamfer, we just drag the tool across that one time.
There you go. So
For a
external
fillet,
edges.
yeah, external edges, chamfer all the way. Um, some shops still use corner round tools, which are basically like a router bit. But most shops these days don't use those that often. So to create an external fillet, we're going to just use the same end mill that we used, to get the floor fillet in here. And we're going to have to take multiple passes across
Yeah.
that fillet to make it round.
Sure, sure. That's a lot of tool movement. You don't,
Mhm.
which is time, right? And that
Right.
reduces your throughput, increases my cost as the designer.
Yeah. So like if I have a tool with a 30 thou corner radius on it,
Hmm.
and you want a whatever 60 thou radius here, I have to go back and forth across this surface probably 50 times before
Right.
it
I can
decides
I
to
can see
pretty
that.
fill it.
I can
Whereas
hear
if it
it
were
now.
whereas if it were a chamfer, I would go across it one time and be done.
Good. All right. I appreciate you taking that question.
Yeah.
Um, Full Front had a good question here on that topic of like oversizing the fillet. Is it a matter of in my CAD model, and maybe this is the perennial question, in my CAD model, should I oversize it or should I on the drawing, should I give you the nominal in my CAD model, 0.25, and then on the drawing, just give you a big tolerance? Or like, how should I help you by making my fillets bigger?
Well,
Um,
to help us, not all machinists are any good at CAD. Um, so the less that you can make the programmer or machinist do, the better. So rather than put it at nominal and then just say you have this wide berth, it would be better for you to put it 10% over nominal, because then we don't have to worry about going in and changing the fillets like we're doing now. And if this weren't a dumb solid and you had a machinist going in and editing fillets that were already in the tree, it might make this whole thing explode. And you don't want that. So me and Jesse here, we've talked extensively about how we really don't like it when there's a unilateral tolerance on a drawing, and
Yeah.
people will model it to the high or the low. So we still kind of want to be in the middle, but we just want those fillets to be 10% bigger than
Okay.
their fractional or metric equivalent.
All right, let's keep moseying. We got 15 minutes, but we were told we could stretch it a few more. So
Yeah,
you said you had another example, guys. Let's shift gears. We got some
yeah,
great chat going on. Continue to share your knowledge and
yeah.
your perspectives, but I definitely want to keep going. Is it the same model or a completely
Yep.
different model?
Nope, we're going to stick in this one, and
All
it's
right,
going
what
to
do you
get
got?
a little bit more complicated, but it's, again, something that, I'll show you guys what these errors are and how to overcome them and go there. So let's just say that we tried to put a fillet in this corner. We tried everything, and nothing would work. So the only thing that we have left is delete face and just delete it. So our goal is the same here, is to get these two edges to come together in a corner. So, logically thinking, I'm going to go into my surfaces workbench. I'm going to go ahead and extend this surface,
Okay.
and
Okay.
the problem with this is as soon as I hit check mark, it's going to tell me no way. Well, why? It just says failed to extend the surface. It looks like it's going to do it. It
I
gives
have
me
no idea
green.
why. Yeah.
And the reason that it won't is because we're creating a self-intersecting surface body right now. So even though it looks like it's not intersecting, these walls are tilted and angled and curved. So this extension may be coming up into this top surface. You don't know. So the way that we're going to get away from that is, rather than trying to extend these surfaces, because we know that won't work. And again, there's other things that we could do that are, maybe a little cooler, but I wanted to show how to get away from this error. So we're going to go to offset surface again, and we're going to give it an offset of 0. So this becomes copy surface now. So we're going to copy these two surfaces that we want to use, and I want to delete the original surfaces. So I'm going to hide that surface offset. I'm going to delete the two faces that were the original, and I'm going to show my new offset surfaces. So now you'll see in my tree I have 3 surface bodies. I got those two and the original. So now if I want to extend this, no problem.
Yeah. Yep. Goes back to what we were saying about 10 minutes ago about body folder. Guy, as I was watching you, I was actually watching your bodies folder on your feature tree. You have to be savvy. It's surface bodies, solid bodies, which one is which. Notice it takes on the name of the last feature. Sometimes you can rename that feature. You can rename the body itself. Like, stay organized so you can follow along with what you're doing, because you're basically created a temporary piece. Now you're going to replace that all into the master part, right? You've kind of created this
Yep.
accessory piece.
Yeah. And now that we have these faces, we can intersect with whatever we want, and it's not going to hurt anything.
Because they're separate bodies, right? It doesn't
Right.
matter. Let SolidWorks now trim them mutually, I suppose. How do you do that?
So I'm going to also untrim this corner here.
Okay, what the heck is untrimmed surface? That's one of the ones I pretend to know what it does, because I'm supposed to, as a CSWE and a almost 20-year user myself. But like, what is untrim again? Can you please
Yeah.
clarify?
So if I want this rounded corner of the floor here to go away, I can extend that surface. But you see what it does? It gives me this big extended fillet thing, and I don't really want that. All I really want is to get that cut corner back where it came from.
So extend
So,
edges. Okay.
so we'll do untrimmed surface, and we just click that one edge, and it's going to extend it. A lot of times, if I'm extending the edge of a surface and I'm getting a bunch of like weird gaps in it or things like that, that clues me in that I need to go untrim that surface first. So we untrim it. It doesn't want to merge with the original face, but that's not a big
Sure.
deal. Just do the same thing we did a minute ago.
Yep.
We'll untrim it, hide that, and we're going to delete the floor out of there. Show our untrim, and now we got 4 surface bodies in here. Now I know that this face is kind of funky here. I can see some weird thick line. So I'm going to just go ahead and delete that face too.
Yeah.
And now we're going to start trimming these walls together. We're going to use trim surface. We can use mutual, which is handy, but just so that we understand how trim is working, we're going to pick our trim tool, and then we're going to pick the thing we want to keep or the thing we want to get rid of. In this case, we're going to click what we want to keep. So it's going to get rid of this little extension at the end there. And then we'll do the same thing the other way. Get rid of our little extension. And so now we have that. Now, at this point, we're going to try to knit everything that we have together. And the reason that we want to do that is so that the final thing will be capping off this rib here at the top again. So we're going to go ahead and try to knit.
I got to ask, have you ever tried the intersect command? Because this workflow you're doing is so quintessential, right? It's overbuild the surfaces and then knit. Well, you're doing a trim back. Thank you. Untrim. I understand that now. And now you're going to knit. But like, I feel like intersect in some cases, you can just throw a bunch of surfaces at it and it will do all this mutual trim. You know, have you ever explored that feature? It was new, like
I actually haven't, and I had somebody ask me that 2 days ago, so I actually planned on looking into it more.
Okay, here's after the show. I would say roll back to where before you do the untrim of any of the radius or anything, and just intersect and throw all the surfaces at it. And what it'll do is like take all that and find you volumes and let you then keep or delete the different intersection volumes it finds, the different overlaps. So it's not magical, but man, it's cool when it works.
I definitely want to try it. So it's always cool when you do a tips and tricks video and somebody else teaches you tips and tricks.
Well, you've taught me a lot. This is fantastic. The chat's loving it too.
And again, this may not be the best application of what I'm showing you, but the purpose is to let you understand why you can't have a self-intersecting surface body, how to get away from that, how to, clone surfaces and reattach them. Because, this, in the end, this is a fillet. So I'm trying to keep it simple, but, at the same time, these carry over on the much more complicated things. Gotta love the forklift starting up. But
hey, we're getting a lot of no, that's great, man. That is legit. We are at your desk right now, which is the coolest desk ever. And you were sharing there's a ton of natural light and this giant bay doors behind you can open up, get a good Texas breeze in the afternoons coming through.
And who else has a cool machine skateboard on their desk, or a metal disco ball, or even the ball in the box, man?
Yeah, guys, as we get to the top of the hour, just got to shout out Titans of CNC. They got this CNC expert, a ton of content. These guys are machining really epic things. As you can see behind Barry, they're also producing a ton of amazing video content. So shout out to their digital team. Definitely check them out. However you get your hands on them. And, you could theoretically learn a lot, or, just get inspired to go make something. Or in this case, we're just learning how to use SolidWorks in maybe a more intentful way to achieve an end, fabrication goal. So we've already gone through a lot of powerful features, split, delete face. We're talking about trimming now. We have maybe we can stretch to about 15 minutes, I think. Then everyone's gonna start tuning out, right? We got to get back to our the real work. Hopefully it's using SolidWorks out there.
Yeah. So I'll wrap this one up quick, but a lot of times when I'm using knit surface, rather than go for the gusto and pick everything, I'll try to kind of give it two opportunities. So I'm going to knit my three new surfaces together. Then I'm going to try to knit it to the original surface, which you can see in the tree worked. So now we just need a filled surface basically up here on the top. I'm going to just do a 3D sketch for the sake of time.
Yeah, convert those into the 3D sketch. What about like a boundary surface? Like, would that work in this many edges?
I think it probably
would.
Boundary
fill sometimes is getting more robust lately.
Yeah, and that's just one that I've been comfortable with for a long time.
Thanks for that tip, Brad. Yeah, boundary surface. There's a lot of surface tools you want to be able to deploy. And you see, it's all about the variety of tools and just deploying them. You're kind of getting into sometimes going face by face. Literally, I'm thinking about yeah, so you got to disassemble to reassemble it the right way. Reconstruct the walls is easier now than maybe trying to, modify the features or whatever the case may be. Just, cut to the nearest stud, put in a new wallboard.
Yeah, yeah. And that's exactly what we did here. And now that we have all of our surfaces created, we'll just do a knit surface with create solid and merge entities in it. Oh, and it hates us. So
What if
to
you
figure
don't?
out what
What if you
happened,
don't? What if you don't create a solid? Sometimes that's like an extra step.
yeah, most of the time when we're working in CAM, we prefer to have a solid. Um,
That's a good point. You
yeah,
need that.
there's plenty that we can do. I mean, we can go into our evaluate and we can do a geometry analysis and it'll tell us what's wrong. Or, sorry, check I meant.
Two open. Yeah,
So
sure.
two open surfaces, got a
Oh
problem
yeah.
there,
Yep.
problem there.
Yeah, that's nice.
Yeah. But, not a big deal. We'll just get rid of that. And we'll try the smart way.
So on that, yeah. So I think we've all been down this road. Like, make sure you're getting all the little entities. Like, you converted them. Like, trying to go fast for us. Select tangency, select open. I wonder though, what if you just left it? You said you want a solid. Is that always the case, or is surface bodies ever used for for milling?
It's not always the case. I mean, we can work with surface bodies, and there's some softwares out there that, they prefer surfaces like Power Mill. But,
Okay.
I'm a Mastercam user and pretty much always have been. So I prefer a solid.
Is there a benefit? Okay, so solid model, and is there a benefit to having the native features when you get to CAM, or is it really about the geometry? So, like at
It's
this
it's
point,
really it's really about the geometry, just
okay,
having geometry there.
yeah. And of course, the CAM software will then look at the geometry and backtrack out, right? Oh, here's my, you know, 3/10 fillet, right? And I'm going to apply this tool in this path and
Yep.
automate that programming. Well, try and automate it. I assume it's not like magic buttons like some of our demos we always make, right? In 3 minutes, we'll program this 12-foot beam that's made out of
Right.
7075, and you just got to push go.
Exactly.
So, by the way, so you ended up machining this out of aluminum. How long was the runtime of this job? Like, how would you describe the complexity? You said it was one of the most complex things you've ever done, but like, is it just the size and the setups? Like, what about it?
Well, what made it complicated in the beginning was just the drawing being, as old as it is, drawn by hand. Everything that I did seemed to not go together properly. Because a hand drawing, you lift off 10 thousandths, that's fine for a hand drawing. But when you start getting into 3D modeling and you want everything perfect, sometimes you don't get that with a hand drawing. So making the actual model was super tough in the beginning. And then, we were making this on a 3-axis mill that just had a 4-axis rotary on it, so we could only spin about an axis. So that made it exponentially more difficult. If we would have had a 5-axis machine, it wouldn't have been that hard.
Okay.
It still would have been very difficult. But all right, so we got our solid body back, and so now we can do whatever we want to it, and it's solid again.
Mm-hmm. Mm-hmm.
But
Can
yeah,
refinish that to your heart's content, and all your features and all your faces should be continuous. Because I also learned from you that, Barry, you can't trust an edges flat. Like, if you're going to quote this and you're like, oh, flat edges or flat walls, this will be easy to
yeah,
do, and then everything's curvilinear, especially in aerospace.
yeah,
It's going to curve in every direction. So you've maintained that in each of your methods.
yep. And every one of these walls was built with splines, as a lofted surface, so they have curvature in both directions, even though it's very slight. It's there. So
Yeah, man. I mean, that was quite the model. I know you can't necessarily show us that. Has a lot of some of the original drawings, but yeah, sketch picture. We got a good response at the beginning of this episode, which is where Barry took us down his last episode with us last year. Talked a lot about sketch picture and how you made this, not this component, but similar components. I guess we have some time. Was there anything else on this spar job
No,
you
no,
wanted to show
I
us?
don't think so. I was just going to show a couple other random tips, but
Yeah, all right. Why don't we take 10 minutes? Let us know in the chat how you're liking this. We had some votes for like an intersect masterclass. I think my guy Brad volunteered for that. So we can definitely do that. Part three, advanced
sweet.
modeling. But yeah, I mean, hey, take 10 minutes. What else kind of top of mind tools are you using all the time?
So, well, one thing that I like is, I've done some pretty big assemblies, to the tune of 14, 15,000 components, particularly aircraft floor structure where you have
Okay.
thousands of high locks and different rivets and uh, different angles and longerons and all this stuff down there. And so some of those assemblies get massive. And a lot of times you're bringing in the same components over and over, but they won't mate to similar faces. So, if you're bringing in multiple instances of the same component, um, most of the time you'll use copy with mates. Like say you're putting a rivet
Sure.
in a hole, copy with mates. But sometimes you're mating things a little bit different, and you just want to bring in multiple instances of a part. And to do that quickly in an assembly, if you, rather than go, insert components and then browse to your component, you can just hold control on anything that's already exists in your tree, and then just left click and drag it into the graphics window.
Oh, look at that. Instantiating new pieces of spars.
Yes, so now you got multiple instances in there.
Oh man. That's awesome. If you had like mate references set up, I assume you could be snapping those into
Yep,
place.
yep.
Wow,
I just
dude.
I really
Control
like,
drag. Okay.
yeah, just one of those things that you may not know exists until you see somebody else do it. Another, one of my favorite tips and tricks. I don't even remember. I was working at a emergency response vehicle place as a structural engineer, and one of the engineers there, I was, looking at something on his screen with him, and he had a transparent component in front of another component, and
Sure.
I always would rotate around, until I could see the transparent
There's
component.
daylight through there. I can grab it now.
Exactly. And it's like, no, I don't want to pick the part behind it. I want this one
Select
part.
other. I guess you could do a right click, select other, but I never got the hang of that.
Yep. And so what I saw him just randomly click and get the face he wanted. And I was like, what? Dude, how did you just do that? And he said, oh, pick a transparent face. You just hold shift and left click. And it's
Shift
like,
click. Yes. Okay.
yeah. So I was just like,
Fantastic.
man, that just blew my mind. And
Oh,
I don't have to rotate to see daylight anymore. I'm so happy. So,
rotate to see daylight. Oh my gosh. Yeah. So holding shift while clicking gets you the a transparent, or else your default is to select through
right.
transparent. Okay.
Yep.
That's
So
brilliant.
I thought that one was pretty awesome. Um,
You know about tab to hide, right? I mean, I'm not going to teach you anything, but maybe someone
oh,
out
you
there could learn from.
probably will. Tab will hide a component. I don't know about that.
There you
Oh,
go.
wow.
Okay, wait, go back. Put your mouse back where that was, and do Shift Tab. So tab, and then Shift Tab will reveal it back, so you can like dig down in an assembly, be like Shift, or sorry, Tab, and then Shift Tab to bring it all back.
I did not know that.
Oh my gosh! No, you're you're humoring me.
I'm not actually. I like
Oh,
that one.
there
But
you go.
again, it's just one of those things that exists out there that until you see somebody else use it or somebody tells you about it, you didn't know.
The thing is, you got to think. Remember, SolidWorks is always built on Windows from the get go, right? That's why it's like easy to use and reminds us of like Office products. And then also, it's going to take advantage of those shortcuts like Control drag, Alt drag, Shift drag. It's going to make Control C, Control V to copy paste, right? All these
Yes.
things to be a better SolidWorks user. Just find the way that works for you, and definitely try your keyboard modifiers. And we were talking yesterday too about the graphical nature. Like when you select two items and you want to mate them or constrain them, use those pop-ups. Like if you want to mate like two of these
Oh yeah.
faces planar, just control select and then use the pop-ups.
Yeah. Even something that I learned watching our tutorials that we have on our academy that I had never seen before was the little fillet pop up. Like when you click a vertical edge and then you get that
What do
little
you
fillet
know?
pop up.
No, show us. What do you mean?
I'm not
Yeah,
sure if it'll work on this part, but let me do a new part real quick. It's only take a minute.
Yeah, I'm sure we've all been in this. Like, hey, let me show you this, but I'm always going to start with my box. Let me extrude a new box, and then I can show you.
That's right.
If only I could just take a moment to make a template with a box in it. No, quiet. Some of the demo guys did that. They would have like empty box, just ready to go as a template. But anyway,
I need to do that.
can't take the time to automate. We're too busy.
Right. So I was just watching one of our tutorials, and our CAD beast, Billy, was given the tutorial, and I noticed that when he clicked on this, he went up here to this, and I had never even noticed this pop up before, because normally I'm so busy looking at where my next fillet is that I'm not even paying attention to what pops up.
Sure.
And I saw him, start hovering over the different options here and seeing what was going to change. I'm not sure why it's flashing right now.
Oh, yeah, it actually is not coming through. But yeah, what you should be seeing is like the quick select assistant bar or whatever it is, and it's giving you almost like interpret or forecasting out like what kind of edges you want to select, and you see those purple options that you're probably hovering over.
Yeah, so even though I only picked that one edge, if I pick the first option there, you see it gives me a fillet now in all vertical edges.
I love that.
I love it too, and it was just something that I never paid attention to, and it was like, wow, man, that's pretty time saving right there. Rather than rotating all over or trying to select through a face, just super easy.
Yes. Yep. I'm so glad you showed that one. Can you try and show that one again? Like it did glitch out for a second, but that's such a good one. It's that little quick select. So I guess it goes back to never disregard a pop-up.
Right.
If it comes up in front of your mouse. Yeah, for some reason it's not coming through on the graphics, but that's fine.
Yeah, just know as soon as you click that first edge, take a look at the pop-up that comes up next to your mouse and just hover over each option and see what it'll do, because that'll be seriously time-saving, especially with geometric components like this one.
All right, Barry, give us one more tip, and then I'll wrap up our episode for today. Unfortunately, the next stream is knocking at the studio door here. They need to get in. It's a baking show, so I guess another kind of manufacturing.
All right, I think I'll just show one other thing. And again, this particular part may not be the best for it. We'll go back to our... But a lot of times in aerospace, you'll have to put rivet holes all over these crazy contoured faces and stuff. And it can't just be, like planar normal to this face. It's got to be, the hole has to be perpendicular to the curvature. And one of the ways that I've done that, again, 100 ways to do it, but just a quick and dirty way, especially sometimes where I'll have a lot of this to do. I'll just do a 3D sketch, throw a line on there, make it coincident or on surface.
On surface, okay.
Then I'll make it perpendicular to that surface. And then we could go in and dimension it off of edges or, wherever we need to dimension it from. So now we basically have an axis that's perpendicular to that face at that point.
Oh,
and
perfect.
we can just throw a plane in. And we can pop our hole, knowing that it'll be perfectly perpendicular to that surface.
Yeah, and I'm thinking if you used like a 3D hole wizard, I know that's kind of a bad word sometimes because it's so undefined. But if you had that as a pre-existing sketch, I wonder if that would work to like do a 3D sketch hole wizard and use that existing point. Something we can try. But that's awesome. So because you're using perpendicular sketch relationship to the surface and then perpendicular offset plane. So a great example of just knowing your angles and what you're trying to build there with that axis.
And for a machinist, a lot of times we won't get any of the holes in our models, especially with aircraft parts, because a lot of times they'll omit pilot holes. They'll only want certain holes in there, so their engineers will just give us a part with no holes in it. And then as a machinist, we're left, like with no 3D sketch that we could use hole wizard for. And it's like, oh man, how am I going
to... Sorry, is it a hole table then? XY hole table? Or is it just on the drawing, like crosshatch? Like here's where...
It'll be on the Mylar, where you'll have to measure each hole off of a known feature.
What?
So it'll just say, you know, holes, rivet holes should be perpendicular to surface, and then it's like, here's where they're at. Here's a pretty picture. Have fun.
Wow, man. Okay, so that, yeah, not even going to be on the model, so you might need to add them.
Yep, and maybe you'll only have to, you know, add a couple that are tooling holes. So a method like this, even though it may not be the best method, it is a quick and easy way for you to be able to do that. So yeah, remember that 3D Sketch is your friend.
All right, well, this has been fantastic, Barry. Let's everyone in the chat, if you're still around, thank you so much for hanging out for our 73-minute live design this Friday. Let's give a 1+1 in the chat or whatever you'd like to say to Barry. Thank you so much joining us from Flower Mound, Texas, down to Titans of CNC. You guys, you got to check out their content. They're producing a massive amount of edutainment, type video content, as well as full-length tutorials. CNC Expert is their big thing. You go to cncexpert.com. We can throw that link in the chat, and of course link to it in the description. Big thanks behind the scenes, Ian, Andrew, all the production folks who make this possible. And Barry, would you like to, I guess, shout out anyone or just say anything in closing to the folks watching?
Nah, man, but shout out to everybody who joined today. You know, thanks for hanging out with us. I hope that at least one thing that we went over today is going to help you guys, because you know, over the course of 20 years using this software, those one little things, they add up to a whole bunch of little things in the end, and that's how you end up being faster and better. And the faster and more accurate you can be as a designer or machinist or programmer, the more you're going to be worth in the end. So keep learning those one little things, and
Yeah.
see you guys around.
Oh man, and thank you so much for joining Live Design as a series. Go back, watch last year's episode with Barry. It's easily found in our YouTube channel, live, sort by popular. He had the most views of all Live Design since we started 3 years ago. So thank you once again, Barry. Definitely would love to have you back, part 3, when you have the time. So
Yeah, absolutely.
really value your knowledge. I know everyone did. Thanks everyone so much, and have a fantastic weekend.
Yep. Bye, everybody. Till next time.